Hello and welcome back to the OpShin Pioneer Program for week 2, lecture 3. In this lecture we will delve a bit more into high-level and typed validation scripts. So previously we've seen a really raw validator that did basically nothing, and now we will look at how types are used in on Cardano and how we define them in the contract. So we introduced this contract 42, and this contract actually now checks that the redeemer has a specific type. So if you recall, previously gift did nothing, all the inputs were ignored, and 42 now actually goes ahead and takes the redeemer and checks that it's equal to the integer 42. And this is a bit tedious, so we will also look at the type version of this, which removes some boilerplate. Okay, so let's recap quickly what validation scripts do. They are called when trying to spend funds from an address on Cardano, from a script address. And in the context of this 42 script, we see that, again, the datum, the state of the UTXO doesn't matter yet. But the redeemer, that's the action, that's what you provide when you try to spend the funds from the contract. The redeemer is first taken and then cast into an integer. So, as you can see, the built-in data could be anything. It could be Plutus data, it could be dictionary, it could be integer, it could be bytes. And we just cast it into an integer. So if it's not an integer, this contract will already fail. Right? If you try to provide bytes to this, it will fail. And then in a second step, it checks actually even that this integer is equal to 42. And yeah, that's all this contract does. So let's have a look. Where we log funds again at this contract. So we will use the same as before. We use make gift and then let's have a look. Make gift name script to 42. And yeah, we don't have to actually look at this. It will do the same as before, send some funds with any state to the address. And then we will try to collect the gift. And using Alice and script 42. And now let's try and as you can see here, the redeemer is the integer 42. But let's try to instead pass an empty byte string. Okay, says no UTXO found because this transaction is not on chain. So give it a few seconds. Right. So previously we got no script UTXOs found, which is just here because the transaction was not on chain. But now we try to submit the transaction, and during building the transaction, we actually get an evaluation failure. This means we tried to execute the contract, but we couldn't because there was some error being thrown in the contract. So let's try instead to provide a wrong number. And again, we get a failure. Unfortunately, Blockfrost is very opaque here and doesn't tell us what the error was, but we know what the error was because now we could cast it to an integer, but it was not equal to 42. So let's call it 42. Let's actually pass the integer 42. And now we were able to submit the transaction. So this is also something noteworthy when constructing transactions, is you will never see on-chain the failed examples, because the failed examples, they can actually not be submitted to the blockchain. So failing is something you can only see locally, because these transactions get never executed on-chain. But the successful transactions you can see, and you can then inspect in the Cardano Explorer. This is sometimes a bit annoying when you're trying to find out what exactly went wrong, or how this transaction would look if it would be executed. But then again, it cannot be executed, so it cannot be really inspected well. If you're using Ogmius, you will get a bit more helpful error messages, especially as we later go on to look at traces. But for now, this is okay, because the contracts are very, very small in size. So here you can now see in the contract tab. All right. So here's our transaction, spent funds. We can now also see that it was a bit more expensive. We had a bit more memory steps, a bit more execution steps, because now the whole script invocation was more involved. We did actually, the script is also slightly longer. And you see that the value is now an integer 42. Again, we had some collateral and we had the script executed. Okay. So now you might think, okay, do I really need to cast this always into an integer? And no. Let's have a look at the typed version. We can just specify as a type for this argument integer. And then what will happen on chain is that, or behind the scenes in OpShin, is that basically this cast that we did here will be performed already in the before the validator is invoked. So actually, the redeemer will then be already in integer form, and then we can compare it to 42. So yeah, you can also see the other types have been typed. The context is generally of form script context. This is what the node provides us. And we will delve deeper into this in a later lecture. And then we have the datum, which we just describe as none here because it doesn't really matter. And you can run this and try to see that it will give you the exact same that it will give you the exact same behavior as the untyped script, where you did the manual conversion. All right. And generally, we recommend that you always cast to these types because they just give you more information to work on and make it easier to handle your contract. Right. This was a very short introduction on how to use these untyped validators, but we will from now on always use typed validators. That's just because they are much more intuitive. And right, we will type all datum, redeemer, and context, and then you can usually expect on what you work with. Okay, that was all for this lecture, and see you in the next one.